Students, this is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 2, Exercise 2.8. In Exercise 2.8, we are going to study about definite integral. So far, we have learnt about the indefinite integrals on elementary algebraic, exponential, trigonometric and logarithmic functions. So far we have completed indefinite integrals only. Now only we are going to study about the definite integrals. Okay, integrals of the type a to b, this is called the lower limit of the integral, that one is the upper limit of the integral, f of x dx. It is also represented as the area bounded for the curve y equal to f of x between the ordinates x equal to a and x equals b. X equals a and x equals b. Here we have two fundamental theorems. First one is the first fundamental theorem of integral calculus. If f of x is a continuous function and f of x is equal to integral a to x f of t dt, then capital F dash of x, that is equal to small f of x. And theorem 2.2, second fundamental theorem of integral calculus. Particularly in this exercise, we are going to study about the second fundamental theorem of integral calculus only. Let f of x be a continuous function from a to b. This is a starting one and the ending one. That's from a to b, it is continuous. If capital F of x is antiderivative of f of x, then integral a to b f of x dx, that is equal to f of b minus f of a. Okay, antiderivative means integration. Integral a to b f of x dx equals f of upper limit is b minus f of the lower limit a. Okay, here what is given? Here a and b are known as the lower limit and upper limit of the definite integral. Now we can get into that problem exercise 2.8, integral 0 to 1 e power 2x dx, using, look at that, second fundamental theorem. Shall we start? Very simple only. Just you have to integrate. After the integration, you have to apply the limits. First upper limit and followed by the lower limit. Okay, what form it is? E power 2x. We know that e power ax dx formula 1 by a into e power ax. Here, if you are given the limits, you are not supposed to introduce a constant. Generally, we are introducing constant at the end of the integration. Here, no need to use that constant. That is the only difference between a definite integral and indefinite integral. For definite integral, no need to introduce the constant. Remember, that is very important point. Now, I am going to apply the formula. Okay, which one is a here? A is the coefficient of x. What is the coefficient of x? 2. So 1 by 2 according to this formula. E power ax, that is e power 2x as it is. Don't introduce c, right? Now you have to apply the limits. That half, let it be outside. The constant, let it be outside. What are the limits? 0 and 1. That is equal to half, right, as it is. Apply the upper limit, that x has to be replaced by 1. After that, x has to be replaced by 0. That's all. So I am going to replace e power 2 into 1. Upper limit is over. Minus, I have to introduce minus. E power 2 into 0. Upper limit minus, then lower limit. That is equal to half e power 2 ones are 2 minus 2 into 0, 0. That is equal to half e power 2, right, as it is. Anything power 0 is always 1. So e power 0 equals 1. That's all. Problem number 1 is over. I'll be teaching problem number 2 in the next video. Thank you, children.